Welcome to ClickMyProject.com. The project title is Differentially Private Frequent Item Set Mining via Transactions Abstract. In this paper, we study the problem of designing a differently private FIM algorithm which can simultaneously provide a high level of data utility and a high level of data privacy. This task is very challenging due to the possibility of long transaction. A potential solution is to limit the cardinality of transaction by truncating long transaction. However, such approach might cause too much information loss and result in poor performance. To limit the cardinality of transaction while reducing the information loss, we argue that the long transaction should be split rather than. In existing system, a variety of algorithms have been proposed for mining frequent item set. Existing work presents an a priori based differentially private FIM algorithm. To limit the cardinality of transaction while reducing the information loss, we argue that the long transaction should be split rather than truncated. To this end, we propose here transaction splitting based differentially private FIM algorithm which is referred as a priori. In particular, a smart weighted splitting technique is proposed to divide long transaction into subtransactions whose cardinality is no more than the specified number of items. In addition, to offset the information loss caused by transaction splitting, a support estimation technique is devised here to estimate the actual support of item set in the original database. Let's see the data flow diagram. The proposed system presents our private FP growth algorithm, which consists of a processing phase and a mining phase. In the pre-processing phase, we transform the database to limit the length of the transaction. The pre-processing phase is relevant to user-specified thresholds and need to be performed only once of the given database. We devise a novel smart splitting method to transform the database. The main advantages is it reduces the amount of noise. Such techniques are not only suitable for FP but also can be utilized to design other differentially private FIM algorithm. After the transformation of the database, the support of the frequent item sets will not be affected. It has been shown to provide good results and has no load time complexity. The advantages of PHP over TT is basically the same as that of FP growth over a priori. Let's see the data flow description. First one is store transaction. Store the customer purchasing details to database each transaction. Second one is split transaction. The split transaction divides the transaction into multiple categories representing, for example, the different item bought with a single purchase at the store. To improve the utility privacy trade-off, we argue that long transactions should be split rather than truncated. That is, we transform the database by dividing long transaction into multiple subsets, each of which meets the maximum length constraint. The next process is runtime estimation. And the estimation frequently purchased items at runtime and then dynamically reduce the unwanted details. To offset the information loss caused by the transaction splitting, a runtime estimation method is used to estimate the actual support of item set in the minimum process. Furthermore, to lower the amount of added noise, we developed a dynamic reduction method which dynamically reduces the sensitivity of support computation by decreasing the upper bound of the number of support computation. The another process is find frequently purchased items. Find maximum and average purchase items from transaction. To improve the utility and privacy trade-off, TFP and TT transform the database and add noise to the support of the item sets in the transformed database. Due to the privacy requirement, it is hard to previously quantitate the information loss for every specific item set. Thus, for the support of released item set, TFP and TT introduce more errors than PB due to the transformation of the database. On the other hand, we observe TFP gains comparable transform with PB in terms of RE in most classes. To the best of our knowledge, our work is the first effort to consider frequent item set mining in the set of differential privacy. We have precisely quantified the trade-off between privacy and utility in frequent item set mining, and our result indicates that in order to specify a non-trivial utility requirement, a frequent set item set mining algorithm incurs a huge risk of privacy breach. Welcome to see the project. If you are a new registered user, click here. Now, if you are a new customer, you need to register your details and your last name. Click your date of birth. Choose your gender and the contact details and enter the address and the postal number. Enter the email address. I am typing my customer ID and the password. For the security, we have to raise the security question. Now click register button. Thank you.